Hello, everyone. My name is Dali from Kyoto University. And today I'm pleased to have this opportunity to present our research, a sentiment strange extraction method considering the effect of memory for bicycle navigation. And nowadays, mobility in urban environments is becoming one of the most interesting research fields in the smart city. As an important foundation of the smart city, Mars provides a seamless passenger experience using multiple modes of transport from the beginning until the end of the journey. Moreover, as the last mile of the Mars, electric bicycle is an important and environmental friendly transportation. So, a comfortable bicycle navigation system is of great significance to support this mode of transportation. In this study, we propose a sentiment strength calculation method considering the effect of memory to realize the safer and comfortable route recommendation for bicycle users. In recent years, many recommendation systems that consider the influence of time interval have been proposed. In contrast to this study, we consider the influence of memory in different time intervals and sentiment strength evaluation of the scenery on the road. And here is the overview of the proposed system. A mobile phone on bicycle is used to capture facial expressions and provide an application for navigation service on the mobile terminal. In this application, the user first need to enter the destination, and mobile terminal send the coordinates of the destination and current position to server. The server returns two routes, the shortest route and the proposed route. After the user select a route, the server starts obtaining facial expression images with location and time data. Specifically, and firstly, a mobile terminal captures facial expressions at certain time intervals during riding. Secondly, the sentiment in the image data is determined via a real-time sentiment analysis API in the server after receiving the facial expression images, location information, and time data from the mobile. And the image data are divided into analyzable data and unanalyzable imaging. The imaging analysis results are used to label the locations at which the images were captured. Then, after arriving at the destination, the road images are selected based on the coordinates of the extracted facial images and sent to user after certain time has elapsed. Explicit evaluation scores indicating how comfortable the user felt turning the right route using a 5-point Likert scale are received from the user. The weighted explicit potential feedback scores are combined to calculate the sentiment strength of the road and facial imagery. We observed that the potential feedback results analyzed using the facial expression analysis tool via the sentiment analysis API depends on the factors such as weather and imaging angles. There's a probability that the data reliability may be low when the results are used as sentiment labels. And there are even many analyzable images. Therefore, we combine the weighted explicit and the potential feedback scores to calculate sentiment strength. And we ask the user to evaluate the images extracted using potential feedback results to obtain explicit feedback considering the impact of memory. We utilize a 5-point Likert scale to obtain explicit feedback from user and calculate the final sentiment strength S, where the sum of the weights lambda is equal to 1. As the scenery that is memorable for a longer time is considered to have a stronger sentiment strength, we utilize a greater weight lambda 2 for the explicit feedback received after a long period of time. SA is the potential feedback results. determined using the sentiment analysis API. Its you donate the evaluation results of the 5-point Likert scale. In the implementation, we used Google Pixel 5 as the mobile terminal. For the backend, we utilized Python, Flask, MySQL, and Apache. Here is the application user interface on the right. And we used the Microsoft Other as the facial expression analysis tool. The face detection results of Other contain 8 scores across 8 sentiment categories. We use the implemented application to obtain root data and analyze the results. Using the proposed system, users are photographed to capture their facial expression every 3 seconds. These images are transmitted to the server, and real-time sentiment analysis is performed using Other. We asked 5 bicycle users to ride for 50 minutes while using our app in Kyoto, Japan. A total of 7,658 facial expression images were obtained. Each of these images were sent to the user to obtain explicit feedback, and they were asked, "How did you feel when you wrote here?" After receiving the facial expression pictures and the sentiment analysis result, analyzable images were selected for explicit feedback. We used the geographical information of these pictures to obtain images of the surrounding scenery and the road conditions through Google Street View. And here are the results of sentiment strength calculation. The time of user evaluation was 1 day after the writing day. Lambda 2 was set to 0.6. And first day after writing is 0.7, and the 7th day after writing is 0.8. We observed that the average value of user evaluation scores changed over time, verifying our hypothesis concerning the effect of memory. When riding a bike, users may not provide positive facial expressions even in the presence of good scenery due to poor conditions such as traffic. Therefore, high contempt and neutral scores were obtained in many cases, an issue that can be overcome using the proposed sentiment strength calculation method. There are many cases where no values are obtained in all categories, such as the image ID 937. These images cannot be analyzed by Other because the problems such as the angle of the mobile phone, the angle of the facial imaging, and weather. In this paper, we utilized 2 methods to obtain user feedback to acquire reliable training data for bicycle navigation. We used the Other API to obtain potential feedback values, extracted the location of the automatically labeled images, and obtained explicit feedback from users. And we considered the impact of memory on the explicit feedback. And we combined the weighted, explicit, and potential feedback scores to calculate the sentiment strength. And finally, we verified the influence of memory on the sentiment strength. In the future, we plan to propose machine learning models for each user, where the sentiment of the unanalyzable image will be predicted, and the locations of images with positive sentiment value will be used to generate comfortable routes for electric bicycle users. In addition, the experiment conducted in this study used only happiness value to obtain potential feedback. However, the results of all 8 categories should be considered in the future research. This is the end. Thank you for your attention.